Okay, in this video I'm going to explain to you how to perform a hypothesis test using a critical value when you're doing section 10.3 testing the mean. Let's suppose we have this scenario. We need to test that the mean is greater than 15. You are given n, you are given x bar, sample mean, you are given sample standard deviation, and alpha, which is 0.05. The next step is to find the test statistic, which you could do it by hand. If you like, x bar here is 16.23 minus mean. We assume that the mean is true, is 15 until proven otherwise. S is 2.34 divided by square root of 23. And actually, to find the value, this is what I'm going to do. I'm going to go to t-test. Mu 0 is 15. X bar is 16.23, S is 2.34, N is 23, and we're testing that the mean is greater than. Calculate T is 2.521, and that's all I need. Actually, the p-value, if you're using the p-value, you can see you get the p-value, compare it with alpha, and since this p-value is alpha, you reject HO, but we want to use a critical value. So I'm only going to get the calculator from the calculator is the next step, 2.521. Okay, how does the critical value work? Let me explain that to you. You take alpha. Since this is a right tail test, greater than, it's a right tail test. You shade an area toward the tail, and this area is going to be alpha. And what you need to know, what is this value right here, for which the area to its right is alpha, which is 0.05. Now, how do you find this one? This is TC, critical value. C stands for a critical value or a critical value here. To find this value, you can use, you can go to second variables, which is distributions, and you can use inverse T. Inverse T requires two arguments only. The area to the left of your target, since the area to the right is 0.05, the area to the left will be what? 0.95. And then the degrees of freedom. The degrees of freedom of the sample size minus 1, which is 22. So let me show you how to do it. Second, distribute, and you go to inverse T. You put 0.95 and you put degrees of freedom, which is 22, and paste, and you get 1.717. Now let's say you make a mistake and you still use 0.05 here. Let's do it. That's okay. You can still manage with this. Watch. Let's say you did not do 1 minus 0.05. You did 0.05. Degrees of freedom, paste. Okay, you get negative 1.717, but since this is a right tail test and everything you have on the right, to just get rid of the negative sign and use 1.717. Okay, so I have this value to be 1.717. Now I go to the test statistic, which is 2.521. If you place it on the number line, where would that place? It will place here, above 1.727, so 521. So it is in the rejection region. And then you end up what? Rejecting HO and supporting the claim. So this is how the critical value works. Now, if you have a less than, your critical value will be here on the left. You shade on the left and you do inverse T of 0.0522. So you'll get a negative value. The only difference, guys, if you're not using the table, if you have a two-tail test, you will have a rejection region on the right and a rejection region on the left. So you have to split the alpha into on the two regions, so it will be 0.025 and 0.025. So when you do an inverse T, you do it on 0.025. You can also use the table that is provided for you, and I have a video showing you how to use the table if you want to find the critical values. So this is how you find the critical values. However, if the question asks for the p-value, you can simply just use the t-test and get all the answers using the t-test here, which we just did. You get t and you get the p-value. And as you can see, the p-value here is less than alpha, so you reject HO.